Hello. I wanted to go through this review with you in case you wanted to see these problems worked through again based on how I taught it in class. So at any time, if you just want to pay attention, fix your answers, pause it, rewind it, move forward, go ahead to just specific problems that you need. Kind of use this at your own leisure to kind of serve your own needs. Okay, so I'm on page 11 of the practice packet. It does say evaluate or simplify, which is the majority of what we'll be doing, the following expressions. So remember that means to write answers with positive exponents after applying all the rules. Exponent rules. Okay. So, excuse me, that's a good review of what you're going to have to do here. So, here, really the only rule that can be applied is that y to the 0 is 1, so you can kind of ignore that. So this final answer for number 1 is just negative 2x cubed. Okay. Number 2, you know that when you square a product with two factors, right, like this, you're going to have to square both of them. So this is 7 squared times w squared, and I would expect to see 49w squared on the line. Here we have a product, each having exponents, so we can just add the exponents. So 2 plus negative 2 is 0, right? And so my answer would be 1. Again, just multiplying these two terms, two expressions together, add the exponents because they have the same base. The coefficients, 2 times negative 5 is negative 10. And then adding the exponents, I get x to the 7th power. Number 4, before I can multiply by this 4, I have to square this term here. Think about what you do with these two exponents, right? Since you're raising this power to this power, that's multiplying the exponents. So your coefficient would be 4, and you would have x to the 4th as your power on the x. 6, I believe this is the opposite here, this little negative, of negative 5 squared. So you could think of this, like this here. You're squaring negative 5 to be positive 25. But then you have that opposite sign, right, in front here. So that would make your final answer negative 25. 7 is also negative 25 because this negative is not grouped. Remember, this is like the opposite of positive 5 squared is how I would think of this. Okay. Number 8, we have this negative exponent, so that means we have to kind of make it happy, right? So I'm going to take the reciprocal of this and square it. So I'm going to have 1 over negative 5 squared. That's really what it's asking. Okay. Either way, you would get 1 squared and then negative 5 squared. Okay, and so that would be 1 over positive 25. Okay. Another way to think of this, right, for those of you that like to do that, is to just put this in the denominator. So it's 1 over negative 5 squared, like this. And you notice you would get the same answer. Okay. Number 8. Again, now the 5 is just to the negative 2. Okay, this is kind of separated, this negative, because it's not grouped like in number 8. So you basically have negative 1 in your numerator, and then you have 5 squared in your denominator, right? So this is negative 1 over 25 for number 9. 10, we see this division sign, right? So we're going to go ahead and divide by subtracting exponents. So the bigger number's on top here. So I have x to the 5 minus 3, so I have x squared. And then since the power of 8 on the y is in the denominator, I'm going to subtract 8 minus 4, and I'm going to put that in the denominator here. So your answer is x squared over y to the 4th. 11, I'm going to multiply these before dividing. So I get 12a to the 4th divided by 6a squared. The coefficient would be what? Think about it for a second. Okay, 2. And then I would just have a squared when I subtract those. Same base. Number 12, lots of t's here, so I'm going to try to break that down. Again, I'm going to multiply the denominator first. So I'll just rewrite this. And then this becomes 20t to the 4th if I add the cubed and the power of 1 that's not written there. So now I reduce this using the fraction feature of my calculator, right? Dividing each by 5, I get negative 1/4. And then I get the t cubed when I subtract, but it goes in the bottom because that's larger. So I have negative 1 over 4t cubed for my final answer for 12. Okay, Going on to page 12. 13. Ooh, so much going on in 13. Okay, let's zoom in a little bit here so you can see this work better. Okay, I'm going to do this power in here first, and then probably reduce this and then raise everything to the -1. So the way I look at this, I would do x to the 10th, just handling this, and then rewrite x to the 8th. This is all to the -1, which just means the reciprocal of that. Okay, so you could do that way. I would probably subtract these exponents and get x squared to the -1. Right, do the quotient first and then raise it to the -1. So that would actually end up being, when I multiply these two, x to the -2. And then I would rewrite that to make that a happy exponent as 1 over x squared. 14 is awesome. This whole big quantity is to the 0 power. Woo! Take a break there, right? Get an answer of 1. 15 is mean. Okay, so we've got negative exponents in here, and then we have a -3 power out there. Much like number 13, I would take and simplify what's going on in here first. So I would multiply this together, and this negative sign I will just ignore for a moment and rewrite it. So in here, 5 times c to the 5th times c to the -3 would be adding those exponents, which would be just c squared. And then you still have over c to the 4th. So that's just for simplification here. Okay, now I would go ahead and subtract these, right? So I would have a -1 in my placeholder because the bigger exponent's in the denominator. So I would have -1 over c squared to the -3rd power. So I could take the reciprocal of this and get c squared over -1 to the 3rd power. If I wanted to remove this negative, okay? So I get c to the 6th here and a -1 here. C to the 6th over, again, -1 cubed is just -1, which I can write that anywhere. So I'm just going to write that -1 in front here and have negative c to the 6th. That's a hard one, really hard. So this is kind of as hard as it gets. If you can do this problem, 3 stars, right? You're doing a great job. Scientific notation, simplify first if necessary. So I'm going to move this decimal point 1, 2, 3, 4 to get 6.3 as my lead characters here, and then times 10 to the, remember that was 1, 2, 3, 4 decimal places. So I would like this number to be smaller, so I would make my exponent -4. Okay. Here, 4.5 divided by 9, I would have 0.5 for my lead value, right, when I divide these. Right, you could just simplify that fraction. So let me show you here. 4.5 divided by 9, math, enter, enter, leaves me with 1/2 for my coefficient. So I'll write that as 0.5 for now, and then times 10 to the, when I do 3 minus 7, right, because this is a quotient, I would get -4. Okay, and now again, I'm not allowed to do to have 0.5 as my lead coefficient, right? So I would make that the number 5, and then since I had to move it 1 to the right, I would probably make this to 10 to the -5th. Okay, and so you can check this answer in here. So we would do in parentheses 4.5 times 10 to the 3rd, right? Divided by, in parentheses, 9 times 10 to the 7th. Let's see what our calculator will do for us. Whoops. Here. Okay. And then you'll notice what it kind of spit. Oh, that's not helpful. Let me get the glare off of here. So I just did the parentheses around the top in the numerator and then parentheses around the denominator and actually hit divide between them. And so you'll see I get 5e to the -5. Right, that's scientific notation for us. This e means times 10 to the. That's the exponentiation notation. So 5 times 10 to the -5th, which we got, is correct. Okay. So here, same idea. I'm going to multiply 2.5 times 2.1 here as my lead coefficients, and I get 5.25, which is nice because that is between 1 and 10. So I'm going to use that in my answer. And then I'm just going to add the exponents. 5 plus -2 is +3. Okay. And then a couple growth and decay functions here. So value of a car depreciates. It's important to note that, right? So, and to turn this 4.5% into a decimal. So that's 0.045. How much will a car that cost $17,250 in 1989 be worth in the year 2000? So let's write our model first. So we're going to use y equals, our a value is going to be how much it cost, right? And then 1 minus 0.045 for our depreciation, right? It's going down in cost to the x, right? So that's my model. And then into this model, I want to plug 8 years in, right? So I'm going to do y equals 17,250 times 1 minus 0.045 to the 8th power. And then use your calculator to evaluate that. So 17,250, or 1 minus 0.045 to the 8th power. Looks like that car will cost, that does not seem right. 1 minus, oh, let's write that down. Y equals 11,934.83. I'll have to double check that. Okay, and then 20, it says the population in the town is increasing, right, at 0.75, so I have to turn that into a decimal again, so I'll move the decimal place twice, 0.0075. How much will it be in 2010? If the population in 2004, that was 6 years ago, was 24,500. So my model would be y equals 24,500 times 1 plus 0.0075 to the x, or t. And then I'm going to go ahead and plug in. I have to figure out that that's 6 years, right? Y equals 24,500. 6. Okay, and again, use your calculator to evaluate that. Such a glare on there. 1 plus 26 years. So it looks like this population might be 25,623. 0.38. Okay, you might put people on this, but you might even then just round it to the whole number, depending on what the directions ask you to do. Okay, that's all. Good luck on the test.